All right, today is our third and final lesson of this mini unit. We're looking at permutations today. So this is a little bit of a switch from probability. So a permutation is just an arrangement of objects where the order is important. So here are the 6 permutations, or six different specific orders that we can put the letters A, B, and C. Oops, this is supposed to be a comma. A, B, and C. So we could start with A, and we could go B, C. We could start with A and go C, B. And then we could start with B and go AC, B and CA. And then finally, we could start with C and have AB and C and have BA. So without actually writing them all out and just guessing and checking, there is a way that we can actually figure out how many choices there are going to be with how many letters or options we have. So first we had 3 choices for what to put first. We could have put an A, a B, or a C. But after you pick the first letter, you only have 2 choices left for the second spot. You could put B or C here, and then finally the third spot could be filled with whatever was left. So we had 3 choices for the first spot, 2 choices for the second spot, and 1 choice left for the third spot. So we really, if we multiply these, we get our answer of 6. There are 6 different ways we can rearrange the letters. 3 times 2 is 6, 6 times 1 is 6. There are 6 ways we can rearrange the letters. Let's look at a different example. It says use the word July for questions 1 and 2. And how many ways can you arrange all of the letters? So we could, if we wanted to write it out, we could start with the J, and we could say U and then L and then Y. Or we could say J and then L and then U and then Y. We could go on and on and on and list out so many different options. But we know that there are 4 spots for the word July. The first spot here, we have 4 choices. We could put a J, a U, an L, or a Y. But once you pick one, you only have like 3 choices left. Once you pick one again, then you only have 2 choices left, and then finally you're only left with whatever's left, 1 choice left. So this is a permutation, or figuring out how many ways can we find the number of rearrangements. We are just multiplying these numbers. 4 times 3 is 12, 12 times 2 is 24, and 24 times 1 is still 24. So there are 24 different ways we could arrange those 4 letters, J, U, L, and Y. Now they're asking, how many ways can you arrange only 2 of the letters? So we want 2 letters side by side. We could have like J-U, we could have J-L, we could have J-Y, we could have U-L, we could have U-Y, like U-J. We could keep going on and on. So right away, whatever our first spot is, we had 4 choices of what we could put there. A J, an U, an L, or a Y. And then for the second spot, we had 3 choices left. So, and how many ways can you arrange only 2 of the letters? There are 12 ways. We could have 3 for J, 3 for U, 3 for L, and 3 for Y, starting with Y. So there are only 12 ways to arrange groups of 2 of them. Let's look at our next slide. This is actually explaining what we just did. It says in the last example, we evaluated 4 times 3 times 2 times 1. This can be written as what we call 4 exclamation point and is read as 4 factorial, which means it's just the product of these consecutive integers to 1, from 1 to n. So this one was from 1 to 4, 1 times 2 times 3 times 4. This is called n factorial. And just so you know, the value of 0 factorial is 1. There's one way to arrange 0, right? It's just 0. So here, 5 factorial is starting at that number 5 and multiplying or finding the product of every number below that, consecutively down to 1. 5 times 4 times 3 times 2 times 1. Now, we can multiply this out using our calculator, 5 times 4 times 3 times 2 times 1, using our head, or I can actually show you where on your calculator you can find the factorial button. There's a button that actually is factorial, so you don't have to solve it. I'm going to do this in my head. 5 times 4 is 20, and then we have times 3 times 2 times 1. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is still 120. So we just did that one with what we know about multiplying. So 5 factorial is really 120. There are 120 ways to arrange 5 different objects. Next, if we only have 3 objects, how many ways can we arrange all of them? 3 times 2 times 1. We actually did this with the letters CAB. 3 times 2 is 6, times 1 is still 6. 6 ways to arrange those 3 objects or letters. 8 factorial, this one's big. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's a lot of work. I'm going to start off with just plugging this one in my calculator because it's going to be a really big number. If you already know what 5 factorial is, isn't this 5 factorial right there? 120? And then you're just multiplying it by 6 and 7 and 8. So I'm just going to take 120 times 6 times 7 times 8 in my calculator, and I get 40,320. There are 40,320 ways to arrange 8 different letters or numbers or objects if we were to list them out one at a time. That's why we're not going to actually list them out. That's why we have this formula or this factorial to help us. Next, we have what's called a permutation. So a permutation is the number of ways you can arrange objects where the order matters. We talked about that already on the first slide. N is the total number of objects. That's what we've discussed. And this new letter R is the number of objects you are looking for at one time. So this is actually what we did right here. So we have a formula or an equation to help us. So how many ways can we arrange all of the objects? So a permutation here, we want n objects all of the ways. So if we're looking at 5 objects, I have a shoe, a hook, a cracker, an elephant, and a candle. And I have those 5 objects. I want to know how many ways can I arrange all 5 of them. It's just a factorial. Like here, if I have my 5 objects, I want to arrange all 5 of them. I have 5 choices. 5 times 4 times 3 times 2 times 1. Now you can plug that in your calculator, or you guys, we did that right here. The answer is 120. There are 120 ways to arrange all of those objects. Okay? But now, what if we only want to arrange some of the objects? N tells us how many objects there are total, that first number. R tells us just the part that we're looking for. So we have 7 objects, but we're only arranging 2 of them. 2 objects is all we're looking for. Just like we did earlier, we have 7 choices for the first one and 6 choices for the second one. Now, why are we doing this like this? We really have an equation to help us. We could do n factorial, which is 7 factorial in this case, because our n right here, and this is r. Originally, if we wanted all 7 objects, we'd have that many options. On the bottom, we're dividing by n minus r factorial, so 7 minus 2 factorial, which is really 7 factorial over 5 factorial. So if I were to write that out, I'm just going to do it down here. That would be 7 times 6 times 5 times 4 times 3 times 2 times 1. And on the bottom, we'd have 5 times 4 times 3 times 2 times 1. Now, this is a lot of work. I'm not going to solve all that. Because this is all just multiplying and dividing, we can cancel. So those all cancel out, and we're left with just 7 times 6, which is exactly what we did earlier. We have this big equation, but it's really just 7 times 6 because we're only arranging 2 objects, and we have 7 objects to choose from. So we have 7 choices for the first one, but once we pick one, we only have 6 left. So we still get 7 times 6, or 6 times 7, which is 42. There are 42 ways we can arrange 2 objects out of 7. So this next one, we can think of it the same way. We can look at, hey, we have 5 objects total, and we're arranging only 3 of them. So we have 5 times 4 times 3. Or, what you're really doing is you're doing 5 factorial divided by 5 minus 3 factorial, which is 2. Right here, you're just subtracting. If we were to write that out, 5 times 4 times 3 times... I'm just going to stop at 2 factorial, because 2 factorial is still 2 factorial. They're going to eliminate. It's just 2 times 1. So we just have 5 times 4 times 3, which is exactly what we had here. 5 times 4 is 20. 20 times 3 is 60. 60 ways to arrange 3 objects when there are 5 choices. Next one, we have 6 permutations of 5, meaning we have 6 total objects. We want to arrange 5 of them. So we have first 6 choices, then 5, then 4, then 3, then 2. Now this is the same as 6 factorial over 6 minus 5 is 1 factorial. 1 times 1 is just 1. So this is really the same as what we just said, 6 times 5 times 4 times 3 times 2, because our 1 factorials cancel out. 1 times 1 is just 1. So 6 times 5 times 4 times 3 times 2, we could plug in our calculator. I don't think we've done this one yet. 6 times 5 times 4 times 3 times 2 is 720. There are 720 ways to arrange 5 objects when you have 6 to choose from. Alright, we're going to move on. We're going to look at a couple examples. It says your band has written 12 songs and plans to record 9 of them for a CD. And how many ways can we arrange the songs on the CD? So if we think about this in terms of our equation that we have, how many total songs we have to choose from, and the part that we're looking to arrange. So this would be written as 12 permutations of 9. Okay? And how many ways can you arrange the songs on the CD? So this is really, if we follow our formula, 12 factorial over 12 minus 9, which is 3 factorial. So if we wrote this out, we would have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times... I'm going to stop at 3 factorial because that's what we have on the bottom. 3 factorial, 3 times 2 times 1, is going to cancel on both. So we have to multiply all of these numbers. It's the exact same thing as thinking of we have 9 spots to fill, and we have 10 or 12 songs to choose from, then only 11, then 10, 9, 8, 7, 6, 5, 4. The 3's got canceled out because there's 3 spots that we don't even care about. So this is a big, big, big number. We need to multiply these so we can get our answer. 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4, and that is it. Our answer is there are 79,833,600 different ways we could order the songs for our CD. That is crazy, you guys. Huge number. There's so many choices. Alright, let's look at the next one. This one's a little bit tricky, so we need to be careful. It says, for a town parade, you will ride a float with your soccer team. Great, we don't really need that information. There are 12 floats in the parade, okay, 12, and their order is chosen at random. Find the probability. Okay, we're looking for the probability. So we're combining today's lesson with the previous couple days. What's the probability that your float is first and the float with the school chorus is second? Okay?